Recording. Hello, welcome to the 5.1 through 5.4 practice test. A lot of big smiles on my students' faces out there because they get to have their best friend back again. And some of these students in here really needed a best friend, just looking at some of them. They were a little lonely over the last couple of weeks when they didn't have their best friend. Alright, so let's go ahead and get started. Alright, so here we go. Number 1. It says triangle ABC is similar to triangle DEF. Identify the angle that corresponds with B. Well, that's easy. B is right here in the bottom right. So we just go over to the other triangle, and it looks like it's this angle right here. So the corresponding angle is angle E. That's a pretty easy answer there for you guys. Alright, let's do the next one here. I need to move this over a little bit. Sorry about that. Okay, so number 2. Now we have these two similar rectangles, and we want to identify the corresponding side to DA. Well, DA is right here. It's this side right here. So I'm saying it's going to be this side right here, HE. And I'm going to show it's a side by putting an H and an E and put a line over it. And if you notice back here on the other problem, I said this is angle E. So you want to make sure you have the correct symbols for angles and sides. And we will mark you off if you don't put the correct symbols here. So this is the angle symbol, this is the side symbol. Okay, so now we want to know if these two figures are similar. On 1 and 2 they told us yes, they're similar. On this one we want to know if they are similar or not. Well, we're not sure about the angles because we don't know anything about the angles besides this one square corner right here. So what we need to do is look at the sides and see if they're proportional. Well, maybe I'll choose this 12 right here. What corresponds with the 12? That looks like it's kind of the middle side. Well, the middle length side over here is the 4. So 12 over 4, and I want to know, does that equal? I'll put a little question mark over it. And then I'm going to choose the longest side. It doesn't matter which two sides you choose as long as they're corresponding. I'm going to choose the largest side on this one and the largest side on this one. And that gives me 13 over 5. Well, 12 over 4 can be reduced to, let's see here, that could be reduced to 3 over 1, right? Does 3 over 1 equal 13 over 5? No, they are not similar. Their sides are not proportional. Okay, so this is a big no. Alright, a rectangular traffic sign is 18 inches wide, so we'll say it's 18 inches wide here, and 8 inches tall. A rectangular real estate sign, so it's a big old real estate sign, is 27 inches here and 10 inches there. Are the two signs similar? Well, same deal. We know they're rectangles, so their angles are correspondingly equal to each other. But now let's look at their sides. Well, let's see here. I'm going to choose 8. And what corresponds with 8 on the big one over here? Well, yeah, you guessed it. That's 10. And then we're going to go over here. And then I'm going to pick 18 over here. And what corresponds with 18 over here? Well, the only thing that's left is 27. All right, let me just reduce these really quick because I'm not quite sure if they're equal fractions. Well, let's see here. 2 goes into 8 4 times, and 2 goes into 10 5 times. And 9 goes into both of these, so 9 goes into 18 2 times, and 9 goes into 27 3 times. So is 4/5 equal to 2/3? No, they are not similar. This is not proportional. Okay, now we're on number 5, and it says, explain how you know if two figures are similar. Well, what do we know when two figures are similar? We know that two figures are similar when they have two things. Their corresponding angles, that's the symbol we're going to use for angles, angle apostrophe S, are equal, and their corresponding sides are proportional. Okay, so what do we mean here? If we have two figures here, let's say we have two figures, and we're not sure if they're similar or not, and let's say this is 3, this is 4, this is 5, and let's say this is 6, this is 8, this is 10, and let's say I know this angle and this angle are equal, and I know these two angles, that's what those little kind of arcs mean, they're equal to each other. So are these two triangles similar? Well, the answer is yes, and here's why. Because this angle and this angle are equal, because I marked them equal. This angle and this angle are equal. Right angles are always equal. And the sides, well, we have three proportions here. We have 3/6. 3 compares to 6. We also have 4 compares to 8. And we also have 5 compares to 10. And these are all our what we call SRs, our similarity ratios. And if you reduce them all, they all equal 1/2. So you don't have to put all this stuff here, but the big thing on this problem is you would want to show or say that corresponding angles are equal and corresponding sides are proportional. All right, number 6. We haven't done these for a little while, so it's good review. The two figures are similar, and that's key. They're telling us that they're similar to each other. Find the ratio of the perimeters. Now, some of you may be saying, Mr. Roden, how could we find the perimeter ratio? We only know one side of each. To find a perimeter, we have to add all the sides up. But remember, we have this really cool fact that SR is the same as PR, perimeter ratio. So if I know what SR is, it will also be my PR. So let's figure out what SR is. Now, it says we want to go small to large. So I'm going to take the 2.5 off the small one and put the 8 on the large one. Well, that's my SR, but guys, SR and PR are equal. So what is my answer? Yeah, it's just 2.5 over 8. Now, if you really hate decimals and fractions, you could also get rid of the decimal, which I will accept this actually, but if you really did not want a decimal in your SR or PR, you could just multiply these by 2, 2 on top and 2 on bottom, and why would we do that? Because 2.5 times 2.5, what is that? That's 5, right? And 2 times 8 is 16. That would also be true. So either one of these are fine. I'm okay with having a decimal and a fraction. But if you really hate that, just multiply by 2 in this case, and it'll eliminate the decimal. All right. Here, this says the two figures are similar. Find the ratio from small to large of their area. Well, we need another thing. So we start with our SR AR, we want to find AR in this case. So AR is equal to SR squared. Or you can also think of that as SR times itself, SR. Okay, so let's do a small to large. So in this case, our SR is going to be 5/12, but AR is SR squared. So we're going to square this thing, or we're just going to multiply it by itself. Well, 5 times 5 is 25, and 12 times 12 is 144. And you're done. That is the area perimeter. So I'll just say AR is equal to 25 over 144. Great. Okay, number 8. In Spanish, we say ocho. All right, so here we go. Let's take a look at number 8. The ratio of the corresponding lengths of two tables is 4:5. Now, what is that saying? Okay, it's saying that in this case, 4:5, it's saying that SR is equal to 4/5. Okay, that's what SR is, the corresponding lengths. That's the similarity ratio or the side ratio. You can think of it that way. The perimeter of the larger table is 144. So remember, guys, similarity ratio is equal to perimeter ratio. So if we're looking at perimeter ratio, we get 144 on, we just have 44 on the bottom, and the reason why I put it on the bottom here is it says that it is the larger, and the larger one is on the bottom for this one. So we want to figure out what is the perimeter of the smaller table. Well, that is X. We don't know that. So remember, SR equals PR, so we can write a proportion. So this is going to be 4/5 equals X over 44. Okay, now when we solve a proportion, we cross multiply. So we have 44 times 4 and X times 5. Well, X times 5, that's 5X. And what is 44 times, what do we got? 44 times 4? Is that 176? Is that right, guys? They are saying, yes, Mr. Roden, that is correct. It is 176. And so to solve this equation, we are going to divide by 5 to get X by itself. And so you have a little side division problem. You're going to have to take 5 into 176.0. Bring that decimal up. I'm not going to do the whole problem here, but if you do all the math right, you should get 35.2. 35.2, and we're talking feet. When you do this division problem, that is equal to 35.2. Great. So now let's go ahead and do this one. A window is put into a door. It looks like the door to Mr. Roden's classroom. There's a window inside a door, just like that. That's pretty neat. The window are similar, so it's telling us these two are similar rectangles. Cool. The door has a width of 4 feet, so that's 4 feet. The window has a width of 2 feet. The area of the door is 32 feet. What is the area of the window? Okay. So first of all, let me see here. It tells us the area of the door. Area of door. The area of the door is 32 square feet. All right, so let's see here. Well, first of all, let's find SR. Well, SR is equal to 2/4, which reduces to 1/2. But it's talking about AR. So how does AR compare with SR? Well, AR in this case AR is SR squared. So we need to square this answer to get AR. So what is AR? Well, AR is 1/2 times 1/2. 1 times 1 is 1, and then 2 times 2 is 4. So my area ratio is 1/4. Now, I'm not done because I actually need to find the area of the window. So, let's do this. So it looks like we have window over door. So we could write a proportion. 1/4, that's my area ratio, is equal to the window, which we don't know is X, over the door, which we do know is 32. It tells us it's 32. Cross multiplying, we get 1 times 32 and 4x, so we get 4x equals 32, and then we just divide both sides by 4, and we get 32 divided by 4. That equals 8. So it's 8, and we're talking we want the area, so it's 8 square feet. That was a fun problem. All right. If you triple the side lengths of a rectangle, how will the area of the new rectangle be affected? Well, let's do it. So let's say we have a rectangle, and we're going to make it a really easy rectangle. We're going to make it a 2x1 rectangle, and we want to triple the sides. Well, if we triple the sides, that means just multiply by 3. So let's see here. This is going to be 6. And this is going to be 3. Now, what is the area here? This is just 2 times 1, so this area is going to equal 2. And this is going to be 6 times 3. This area is going to be, what is that, 18, right? So, how many times larger is the area of this one than this one? Well, it's going to be 9 times larger because 9 times 2 is 18. So in this case, if you triple the side of a rectangle, you're going to make it 9 times larger. Okay, and just do it. Make a little easy picture here and find the two areas and see what do you have to multiply the smaller one to get to the bigger one. Hopefully, thumbs up out there, guys, if you see that. Awesome. Okay, the last one wants us to solve for the missing side, and they're similar. So what I'm going to do is just set up a proportion. So I like to start with the x because that's what I'm always trying to find. So I'm just going to choose x on this one. What corresponds with x on the big one? Well, 6 corresponds with the x. And then I'm going to go back to the we're going to go back to the little one, and then I'm going to choose the 5. And what corresponds to the 5? Well, 8 corresponds to the 5. And then I'm just going to cross multiply, so I get 8x equals, well, 4 times 5 is, 5 times 6 is 30. And then I just divide both sides by 8. And then I have a little division problem right here. You could reduce first. Maybe you could say this is 15 over 4, and then divide 4 into 15, and you get 3.75 centimeters. All right, let's do the next one. Same thing, I'm going to start with my x. I'll do it over here. X over 4 is equal to, choose the 5 there, and you get 10. So what do we get here? We get 10x equals 4 times 5, I think that's 20, right, guys? All right. Did I do that right? 5 over 10. Let's see here. X over 4, and then 5 over 10. And then I'll just divide both sides by 10, and I'm getting x equals 2. You guys agree with that? X equals 2? All right. X equals 2. All right. Moving on. Okay, so let's do this number 13 right here. So I'm going to choose x over 7 equals, let's see here, 2 over 6. 2 over 6. and then I cross multiply, so I get 6x equals 14. And then what do I do after that? Well, I've got to divide by 6, and so I get x equals, I'm going to reduce this really quick. This is 7/3. And what is 7/3? I think 3 goes into 7, 2.3333 forever. So I'm going to get x equals about 2.3 repeating. And you can do the division to see how that works. Alright, I got carried away here. Let me show you what I did on this problem. I drew Lady Gaga. I guess she was in a movie that was pretty good lately. She was a singer, and she sings songs and all that. I haven't seen it. Okay, so 8/3. It was, Lady Gaga is 8 feet tall, and she casts a shadow. That's 3. And the flagpole, or in this case, it's a lamppost. We don't know how tall it is, and it casts a shadow. That's 15. So we just take Lady Gaga's height, 8, and we compare it to the lamppost height, which is x, and then we go back to Lady Gaga's shadow, which is 3, and compare it to the lamppost, which is 15. Now, what I did is I reduced this 3/15 to 1/5, because 3 goes into itself 1 time, and 3 goes into 15 5 times. Now all I'm going to do is I'm just going to cross multiply. So 1 times x is x, and 8 times 5 is 40. And I'm done. Alright, for the last problem, this is my drawing of the United States, and I think it looks very good and accurate, so don't laugh at it, please. Alright, so here's the deal. It tells us that the map has a scale of 1 centimeter to 40 miles. And the distance from Colorado Springs to Kansas City is 13 centimeters. So it's 13 centimeters on the top and 40 miles on the bottom. So if we're measuring centimeters, we're going to put that on top. Okay? So because centimeters was on top here, and this is an x. Alright, so now we just cross multiply. We've got a nice proportion here. So I'm just going to cross multiply. And so let's see here, I've got 1 times x, which is x. And I've got, then that's equal to 40 times 13. Now, what's 40 times 13? Let me actually just work it over here. 40 times 13, that's a 0, that's a 12. 0, that's a 1, that's a 4. Add them up, I get a 0, I get a 3, and I get a 5. I'm getting, oh, hold on. 0, that's a 12. And then 0 here, we get a 1. And sorry, I messed up, so I went back and did it again. 3 times 0 is 0. 3 times 4 is 12. Bring a 0 down. 1 times 0 is 0. 1 times 4 is 4. We add it up. We get a 0. We get a 2. And we get a 5. So our final answer is 520 miles between Kansas City and Colorado Springs. I think you could probably drive that in one long day. Okay, so hopefully this helps, guys, and you're ready for your final test of second quarter. Good luck.